This is mathheals.com, where you can find more links to YouTube math videos and computer science videos. Let's take a look at linear inequalities in one variable. Now we're going to have different forms. And I'll actually put numbers here instead of A's and B's. I think it clicks better with students. I got x is less than 3. X is, try it again. X is less than or equal to 4. X is greater than 5. X is greater than 6. Greater than or equal to, sorry. 1 less than x less than 3. 1 less than or equal to x less than 4. 2 is less than x less than or equal to 5. And 7 is less than or equal to x less than or equal to 9. We have something called set builder notation, which is very easy. You put curly brackets around it, x with a vertical bar, and then whatever you have over there under the form. So again, x is less than 3, just go straight over there, put curly brackets around it, x vertical bar. Now the vertical bar reads such that. So this is a set of all x values such that x is less than 3. And we'll do the same thing on these. Put curly brackets around it, x with a vertical bar. Set builder notation is the easy one. And just the wind blew something over in my window. That's what I was sitting there mainly looking at my drink to see if there's dirt in it. And all the rest of this carries down. I would shut my window, but it's such a beautiful day. There we go. That's set builder notation. Let's take a look at interval notation. These are different ways of expressing your answer. Now, I'm going to talk through this. Less than means it's going to go to negative infinity. You always put your smaller number here, comma your larger number. Now, less than infinity, going to negative infinity, we never reach infinities. Infinities are large numbers or small numbers you never reach. Like for positive infinity, what's your largest number? Well, 1 trillion? No, 1 trillion plus 1 is larger. 1 trillion plus 2 is larger. Let me open that window a little bit there. There it goes. So you can never reach it, which means we're going to put parentheses on it. Parentheses means it doesn't include a number. Now, x is less than 3 means it doesn't include a 3, so it'll be parentheses there. Now, this one is x is less than or equal to 4, so it's also going to negative infinity. Infinities always have parentheses on them. Less than or equal to, that means it includes 4, which means I put a bracket. Bracket is includes. Now here we got x is greater than 5. That's going to positive infinity. So we're going to have 5, comma infinity. Again, infinities always have parentheses. You can never reach them. X is greater than 5. That doesn't include 5. So parentheses on the 5. This one is x is greater than 6. So x is going to positive infinity. Infinities, again, always have parentheses. X is greater than or equal to. The equal to part means bracket here. Now this one is between 1 and 3. That's less than and less than, which means it doesn't include the 1 and 3. This one's from 1 to 4. This one's a less than or equal to. That means bracket here. And this is just less than, which means parentheses. Line underneath means bracket. This is from 2 to 5. Parentheses, because this is less than. This is a less than or equal to, so bracket on the 5. And this is between 7 and 9, and both of them have the equal to part on them. So the brackets on both of them. Now, a graph is very easy if you got interval notation. Parentheses on a 3, parentheses on a 3. It's going to negative infinity, so I shade to negative infinity. This one, bracket on the 4, bracket on the 4, and it's pointing in the same direction even. It's going to negative infinity, so I shade to negative infinity. This one's 5, parentheses on the 5, parentheses open that way. It's going to positive infinity, which means I shade to positive infinity. This one, bracket on the 6, bracket on the 6. It's going to positive infinity, so I shade to positive infinity. This one's between 1 and 3. Parentheses on 1, parentheses on the 3, so I just carry straight over and you shade in between them. This one, bracket on the 1, parentheses on the 4, shade in between them. And on this one, parentheses on the 2, bracket on the 5, and shade in between them. And then our last one here, 7 and 9, and we shade in between them. Now, you'll find that interval notation will become more popular as you go into college algebra. More answers are written in that form because it's more concise. This graph, you probably won't see a whole lot in a few places. Set builder pops up too. Well, let's work some problems using these. Let's take a look at our first one here. Got negative 2 is less than x is less than or equal to 4. It says write each inequality using interval notation and graph it. Well, this one doesn't. This one has two numbers, and the x's between them. So it's these last four forms. Specifically, this is a less than, and this is a less than or equal to. Less than or equal to is this form right here. That's wanting interval notation. So I come over here. It's going to look like this 2 and 5 with the parentheses bracket, except for instead of 2 and 5, we're going to have negative 2 and 4. So negative 2 and 4. So again, I just looked up the form and matched, and then looked over here to see what interval notation should look like. That's a lot easier than that. If you're without using the table, once you get comfortable with the table, it'll be, less than is always parentheses. Less than or equal to is always bracket. And then it's between two values, so it has to be a smaller number, comma, a larger number. Now, if you got interval notation, the graph is very easy. Parentheses on negative 2, parentheses on negative 2. Bracket on the 4, bracket on the 4. And we're shading in between them. And that's our answer. Here we got x is less than 3. It says write interval and graph. So I come over here, I'm looking for x is less than a number. Oh, that's bad. I actually put 3 up here. So I come over, the interval notation looks like this, and then my graph would look like this. But normally I would replace this 3 here with whatever number's down below. But it's actually 3. Okay, now if I wasn't using that, x is less than, well, that goes to negative infinity. And 3. Infinities always have parentheses. We can never reach them. X is less than 3 doesn't include 3. It has to have the line underneath it for a bracket to include it. Okay, parentheses on 3, parentheses on 3, and I'm going to negative infinity, so I'm shading the negative infinity. And circle that, but that's our answer, and these are our answer. I'm gonna grab a drink here. Okay, write each interval as an inequality involving x and graph it. Bracket, parentheses, 5 and 9. So no infinities, so it's the odd ones. Bracket, parentheses. Bracket, parentheses is this one right here, the 1, 4. So I come over here, this is what it's going to look like, but instead of 1 and 4, I'm going to use 5 and 9. So I got 5 and 9, and even if I didn't have the table, it's pretty straightforward. Bracket on the 5 includes it, so this is a less than or equal to. Parentheses on 9 doesn't include it, so that's just a less than. Now to graph it, if you have interval notation, again, it's straightforward. Bracket on the 5, bracket on the 5. Parentheses on 9, parentheses on 9, and then we shade what's in between it. One more of those. -3, positive infinity. Okay, it's going to positive infinity, so I know what it's going to look like. It's going to be x, and then it'll be something, -3. Now, since it's going to positive infinity, it's going to be a greater than. And since it's specifically a parentheses here, it'll actually be a greater than, not a greater than equal to. Graph-wise, parentheses on -3, parentheses on -3. It's going to positive infinity, so I shade to positive infinity. Like that. Well, if I wanted to match this, parentheses around both of them, a number, comma, infinity. Parentheses around both of them, number, comma, infinity is this one right here, the 5 infinity. So I come over here, this is what it looks like, but instead of 5, we have the number down below. This is what our graph looks like, but instead of the 5, we have the -3 we have in this problem. So let me start a new page. And let's talk about how to solve linear inequalities. So solving linear inequalities. We have our note up at the top. It says at any step, combine like terms and combine numbers. Our first step is to get rid of parentheses. We do that with the distributive property. Our second step is to get rid of fractions. We multiply everything by the LCM of all our denominators to do that. Step 3, get everything so get everything with an x on the left side, numbers on the right side. Technically, you can take it to either side, but to match the table I just gave you, you should have your x's on the left side. And I know you can flip around at the very end, but I like steps to work 100% of the time. And step 4, divide both sides by the number in front of the x. We have a note down here at the bottom. It says if you multiply or divide both sides by a negative number, flip the inequality symbol. So flip the inequality symbol. Less than becomes greater than, or vice versa. Let's look at some problems dealing with this. Let's see, we got 7x minus 2 is less than or equal to 19. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on the left side, numbers on the right side. So I'm going to take the -2, move it to the right side. Just like when we're working with linear equations, when you take anything across your inequality symbol, the sign changes. So -2 becomes a +2. Our note up at top says that any step combine together numbers. 19 plus 2 is 21. Last step, divide both sides by a number in front of the x. The number in front of our x is a 7, so we'll divide both sides by 7. 7's cancel, and we got x is less than or equal to 3. Now it says express your solution using set builder notation, interval notation, and graph it. So set builder. Very easy. You put curly brackets, x is the vertical bar, and then whatever your answer is. Now again, that reads the set of all x values such that that vertical bar is such that x is less than or equal to 3. Now less than, that's going to negative infinity. Infinities always have parentheses on them. Less than or equal to. The equal to part means I put a bracket on that. Now graph-wise, bracket on the 3, bracket on the 3, and it's shading to negative infinity because this goes to negative infinity. Let's look at another one. We got negative 3x minus 2 is less than 13. Now, first step is get rid of parentheses. Don't have any. Second step is get rid of fractions. Don't have any. Third step is get everything with an x on the left side, numbers on the right side. So I'm going to take the -2, move it to the right side. Anytime you take anything across your inequality symbol, the sign changes, so it becomes a +2. Is that really a less than? Yeah, it is. Combine together like terms, combine together numbers in a step. 13 plus 2 is 15. Last step, divide both sides by a number in front of your x. So we're going to divide both sides by -3. If you multiply or divide both sides by a negative number, we just divided both sides by a -3. This says you flip your inequality symbol. So our less than becomes a greater than. Those -3's cancel. And we got x is greater than -5. Set builder, put curly brackets, x with a vertical bar, and then our answer. Interval notation. Well, x is greater than means it's going to positive infinity. So this is -5, comma, positive infinity. Infinities always have parentheses on them. Now specifically, it's x is greater than -5, which means it doesn't include -5. Parentheses on -5, parentheses on -5. It's going to positive infinity, so I shade to positive infinity. Okay. I'll grab a drink here. And let's look at this one. So we've got 4x plus 6 is greater than or equal to 2x minus 10. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on the left side, numbers on the right. So I'll take 2x, move it to the left side, and take 6 and move it to the right side. Anytime you take anything across the inequality symbol, the sign changes. So my positive 2x becomes a negative 2x. My positive 6 becomes a negative 6. Combine together like terms in any step. 4x minus 2x is 2x. Negative 10, negative 6 is negative 16. Now our last step says to divide both sides by a number in front of our x. So we're going to divide both sides by 2. The question is whether we flip that inequality symbol. If you multiply or divide both sides by a negative number, a negative up on top doesn't matter. It's if you're dividing by a negative number. We're dividing by a positive 2. So this just stays greater than or equal to. Some people start seeing negatives, and everywhere they see a negative, they start going crazy and flipping things. And you don't do that. Just with that note I wrote up there. So we're going to have x is greater than or equal to negative 16 divided by 2 is negative 8. Set builder, just put curly brackets around it, x with a vertical bar, like that. Greater than -8, so that means it's going from -8 to positive infinity. Infinities always have parentheses. Now it's a greater than or equal to. The equal to part means you put a bracket on here instead of a parentheses. So -8 to positive infinity. Almost looks like 100. There we go. Graph. Bracket on -8, bracket on -8. It's going to positive infinity, so I shade to positive infinity. Look at number 8 here. Got -2 times x minus 7 plus 5x is less than 8 times x plus 1 minus 5. Okay, first step, get rid of parentheses. This is the distributive property. We're going to take -2 times x and -2 times -7. And we'll take 8 times x and 8 times 1. Now -2 times x is -2x. -2 times -7 is a positive 14 plus 5x. 8 times x is 8x. 8 times 1 is 8 minus 5. Now we multiplied by a negative number. But see what this says. If you multiply and divide both sides by a negative number. This note applies if you go ahead and yourself put the negative on both sides. So you're multiplying both sides by -2 or both sides by -8. Here we're just multiplying a little piece of one side, and so that's not what this is talking about. So this stays a less than. Well, combine together like terms at any step. Here we have -2x and 5x. That's going to give us 3x plus 14. And over on this side, we got 8 minus 5, which gives us 3. Okay. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on the left side, numbers on the right. So I'll take the 8x over to the left side, take the 14 to the right. You take anything across your equal or across your inequality, the sign changes. So this becomes 3x minus 8x is less than 3 minus 14. That gives us, combined together like terms, 3x minus 8x is -5x. 3 minus 14 is -11. Let me double check myself here. Okay. It just seems like this should be a 10, but obviously I didn't design it to come out nice. Divide both sides by a number in front of your x. Now notice we're dividing both sides by a negative number at this point. So we're going to flip our inequality symbol. It becomes greater than. There's no -5's cancel. And we got x is greater than, negative divided by negative is positive. So we got x is greater than 11/5. Set builder, put curly brackets with the x with a vertical bar around it. It's greater than, so it's going to positive infinity. Now specifically it's a greater than, which means this is parentheses, doesn't include that. Parentheses on 11/5, parentheses on 11/5, and then we're going to positive infinity. I know you can't see that very well, but I think you've seen the graphing ones, it doesn't matter that much. Let's look at our next problem. I think most people nowadays probably haven't seen this show. There's a show called The Addams Family that may have seen a remake, which doesn't do the original show any kind of justice. Used to have a butler in there called Lurch, and he was real tall, and they were kind of a spooky family is what it's supposed to be. And every time something displeased him or something happened, he'd go and shake his head. You'd have to see it to really appreciate it. I wish I could get that sound down, though, so every time my tablet hangs up, I can make that sound. Okay. Same instructions. First step, get rid of parentheses. Well, we're going to take the 1/4 times 2x, 1/4 times negative 3. We'll take the 1/3 times x and 1/3 times 1. So we got 1/4 times 2x. We got 1/4 times negative 3. We got 1/3 times x and 1/3 times 1. Now this gives us 2/4 x. I'll go ahead and put it together before I simplify. Minus 3/4. And this is 1/3 x plus 1/3. Now actually, it probably doesn't benefit me a whole lot to simplify this one, because I'm going to immediately get rid of my fractions anyway. And since this denominator here is the same as that, then there's no benefit. Our second step, get rid of fractions. Multiply everything by the LCM of all your denominators. I got 4, 4, 3, 3. So the LCM of 4 and 3 is 12. So multiply everything by 12. When I say everything, I'm talking what's separated by pluses, minuses, and inequality symbols. Okay, 4 and 12. They're both divisible by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. 12 and 4, both divisible by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. 3 and 12, both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. And 3 and 12, both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. Sometimes people wonder why I do it that way, instead of just doing 12 divided by 4 and just putting a 3 up here. The reason why I do this is it's kind of a visual check. If all of your denominators are 1s at this point, that means you picked the right LCM. Well, 3 times 2 is 6. We got 6x. 3 times negative 3 is negative 9. Less than. 4 times 1 is 4x. And 4 times 1 there is 4. Let's see, what step are we in? First step was get rid of parentheses. Second step was get rid of fractions. Third step, get everything with an x on one side, numbers on the other. Or get everything with an x on the left side, sorry. Numbers on the right side. So I'm going to take the 4x, move it to the left side, and it becomes a negative 4x. I'm going to take the negative 9 over the right side and it becomes a positive 9. Combine to get like terms in any step. 6x minus 4x is 2x. 4 plus 9 is 13. Last step. Divide both sides by the number in front of your x. So we're going to divide both sides by 2. This one doesn't come out very nice either. Assuming I didn't make a basic math error somewhere. Those 2's cancel. We got x is less than 13 halves. Now set builder. Put curly brackets around it. X with a vertical bar. Very easy. Interval. It's less than, so it's going to negative infinity. 13 halves there. Infinities always have parentheses. Specifically, it's just a less than, which means parentheses. If you had less than or equal to, it's a bracket. Parentheses on the 13 halves, parentheses on the 13 halves. It's going negative infinity, so I shade the negative infinity. And that's our answer. Let me grab a drink here. Okay, so we got 3/4 minus 1/8 x is greater than negative 3. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. I got 4 and I got 8, so our LCM would be 8. So multiply everything by 8. Well, 8 and 4 both divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. 8 and 8 both divisible by 8. 8 divided by 8 is 1. 8 divided by 8 is 1. So I got 2 times 3 is 6. 1 times negative 1 is negative 1 times x is negative x. And 8 times negative 3 is negative 24. Well, get everything with an x on the left side, numbers on the right. So take 6 over. I got negative x is greater than negative 24 minus 6. Add numbers at any step, combine numbers. Negative 24, negative 6 is negative 30. Last step, divide both sides by a number in front of your x. Well, it's the invisible 1, negative 1 to be precise. So I divide both sides by negative 1. And since we're dividing both sides by a negative number, I flip my inequality symbol. My greater than becomes a less than. So I got x is less than 30. Curly brackets around it. X is less than 30. Like that. Since it's less than a number, it's going to negative infinity. And specifically, it's a less than, so it has to be parentheses. Less than or equal to is where you put a bracket. Parentheses on 30, parentheses on the 30. It's going negative infinity, I shade a negative infinity. And that would be your answer. Assuming no basic math errors, then that's our lesson. So let me save this.